Okay, so when I'm expanding, I'm going to multiply these two things together. That gives me 6x squared. Then I get plus 15x minus 8x minus 20. And then if I simplify these middle terms, I get 6x squared plus 7x minus 20. Okay, I'm going to expand this first of all, which gives me x squared minus 8x plus 16. So now if I expand it all out, I'm going to get x cubed plus 3x squared minus 8x squared from here minus 24x plus 16x plus 48. Simplifying my x squared terms, I get minus 5x squared. Simplifying my numerical, my x's, I get minus 8x, and then I have plus 48 at the end. Okay, moving down, this is difference of two squares, so it's going to be y minus 13, y plus 13. Okay, two ways I could do this. I could do this by inspection, which is where I put the 2x and the x in one bracket. Think about numbers that multiply to give negative 12. So negative 12 is going to be 1 and 12 with the opposite pairs, 2 and 6, 3 and 4. And then looking at those, thinking about which one gives me negative 5 when I expand it, that's quite hard to do. So instead I'm going to split the middle term. So I'm going to look for numbers that multiply to give negative 24. So I'm going to get rid of this. Negative 24. So I've got 1 and 24, obviously the positive and negative versions. And then I've got 2 and 12. And then if I look, I could also have 3 and 8. Okay, there are a couple more there, but I've spotted already that 3 and negative 8 are going to give me negative 5 when I expand it. So I'm going to rewrite this, 2x squared minus 8x plus 3x minus 12. Notice how I put the 8 with the 2 and the 3 with the 12, because I think that's going to be the easiest thing to factorise. Factorise a 2x out, factorise a 3 out, so it's x minus 4, 2x plus 3. Okay, I could have also done that by inspection, and I would have got the same answer. Okay, simplifying, I've got x to the power of 5 and x to the power of 4 on the top, so that gives me x to the power of 9, and I have x squared on the bottom. That gives me x, oops, that's a 9, x to the power of 7. Remembering on B that I need to cube everything, so I'm going to cube 2, which gives me 8, and then I multiply the powers here, which gives me x to the power of 15, 8x to the power of 15. Okay, this one's the most tricky. I'm going to apply the power of 2/3 first. The denominator tells me to cube root, so I'm going to leave my numerator as it is. I'm going to cube root 8, which is 2, and then I'm going to divide my 6 by 3, so it's x to the power of negative 2. I've still got to square that, so then I'm going to do 16x to the power of 5 divided by 4x to the power of minus 4. 16 divided by 4 is 4. X to the power of 5 divided by x to the power of negative 4 gives me x to the power of 9. Okay, I'm looking for the highest square factor of 150, that's 25, so I'm going to write that as 25 times 6. Separate my surd out, and then that's 5 root 6. Okay, expanding and simplifying brackets, same as with algebra, that gives me 10 plus 15 root 3 from 5 times 3 root 3 minus 2 root 3. And then when I do root 3 times by 3 root 3, my root 3's give me 3. So it's 3 times 3, which is 9. So that's subtract 9. 10 take away 9 is 1. And then I've got 15 take away 2, which is 13 root 3. Okay, rationalising the denominator, I'm going to get my first fraction. I'm putting it in brackets because I'm expanding by multiplying by the reciprocal. Not by the reciprocal, sorry, by the conjugate. So I'm going to expand my first bracket, which gives me 7 plus root 5 plus 7 root 5 plus 5. And then denominator I've got 49. That would give me plus 7 root 5, subtract 7 root 5, minus 5. So my numerator I've got 12 plus 8 root 5, and on the bottom I've got 44. It does say simplify, so if I can cancel some numerical factors from this, then that's what I'm going to do. They're all in the 4 times table, so that gives me 3 plus 2 root 5 over 11. Notice how it says it asks me to give it as 2 separate things being added rather than one giant fraction. I'm going to separate that out into 3 over 11 and 2 over 11 root 5. Okay, so on this question, I had something, I did it to the power of negative 4/3, and my answer was 256. I know to undo the negative power, it means find the reciprocal, so x to the power of 4/3 is 256. I'm then going to do the opposite of taking to the power of 4, which is finding the 4th root, and the 4th root of 256 is 4, and then I'm going to cube my answer. So I'm going to do the inverse of cube root, which is 64. You could have positive or negative 64 here. Okay, find the root of f of x. The root is where it crosses the x-axis, so I'm going to set it equal to 0. So I've got 5x plus 2 equals 0. I'm going to take 2 away from both sides, so x is negative 2/5. Okay, find x if g of x equals 20, so I'm going to set this expression equal to 20. Okay, I'm going to take 20 away from both sides, and that is difference of 2 squares, so x plus 4, x minus 4. So x equals positive or negative 4. Okay, solve f of x being equal to g of x, so I'm going to set them equal to each other. X squared plus 4 equals 5x plus 2. I know to solve a quadratic it needs to be in the form something equals 0, so I'm going to rearrange it. I'm then going to try and factorise. There's nothing that multiplies to give positive 2 that adds to give negative 5, so I'm going to use the quadratic formula. Okay, substituting my numbers in, I've got 5 because negative b is positive 5 plus or minus the square root of 25 minus 4 times 1 times 2, so minus 8 over 2 lots of 1. So it's 5 plus or minus root 17 all over 2. Okay, finding the discriminant. The discriminant is b squared minus 4ac. So b here is minus k plus 8, but I know if I square anything negative, it's just a positive. It's the same as the square of the positive. So I'm going to actually ignore that negative because I'm squaring it. If I square it, it becomes positive anyway. So I've got k plus 8 all squared. I need to subtract 4 lots of 1 and then lots of c, 4ac, so that's 8k plus 1. Expanding this out, I get k squared plus 16k plus 64, and then I get minus 32k minus 4. Collecting that all together, k squared minus 16k plus 60. So k squared minus 16k plus 60. If it says to equal roots, that means my discriminant equals 0. If it had no roots, it would be less than 0. If it had 2 distinct roots, so where they are different, then it would be greater than 0. So I'm going to set my discriminant equal to 0. So now I've got a quadratic that I can solve. Okay, I'm going to factorise. So k equals 6 or k equals 10. Okay, it says show that when k is 8, f of x is greater than 0 for all values of x. So I'm going to go back to my f of x because that's what it's referring to, and it says when k is 8. So I'm going to substitute in 8 into here. So I've got x squared. If k is 8, 8 plus 8 is 16, but it's negative, so it's negative 16x. And then I've got 8 times 8, which is 64, plus 1, which is 65. Okay? I'm going to show that it is bigger than 0 for all values of x. I'm going to do that by completing the square. So if I complete the square, I get x minus 8 all squared. I then have to subtract the 64 that I would get from expanding this out, and then I've still got that plus 65 at the end. Simplifying that, x minus 8 plus 1, all the first bit squared. Okay, so this is telling me that I have a minimum at 8 and positive 1. So if I imagine sketching that out, this isn't necessary for the solution, my minimum point is going to be here, which means it never crosses the x-axis. I can also prove that by saying x minus 8 squared is always going to be 0 because anything squared is bigger than 0. And if I add 1 on something which is already positive, it still remains positive. So that must mean, therefore, that's also true. Okay, question 8, it says solve the equation q of x equals 0, give your answer in the form a plus minus 3 root b. So that must mean I need to use the quadratic formula. So I'm going to set, so a is 1, b is negative 10, and c is negative 20. Put that into the formula. So I'm going to have x equals 10 plus or minus the square root of 180 over 2. Obviously you're going to take your time when you substitute that in. When you type that into your calculator, you're going to get that x is equal to 5 plus or minus 3 root 5. You could also simplify it from there. So 5 plus or minus 3 root 5. A is 5, B is also 5. Okay, sketching. It says, sketch both the graphs on the same set of axes and label all the points where the curves intersect the coordinate axes. First thing, really important, always label your axes with x and y. If you don't have your axes labelled, then you are not going to get full marks. Okay, I'm going to focus on plotting the straight line graph first, so p of x. So p of x is 3 minus a half x. I need to think about where that is going to cross the coordinate axes. It's going to cross the x-axis when y is 0. So if I'm plotting this line equals to y, y is going to be 0, so I need to find the value of x. If 3 minus a half x equals 0, x is going to be 6. 3 take away half of 6 is 0. Or I could solve by adding on a half x times by 2, x equals 6. So that's when y equals 0. When x equals 0, if I substitute 0 into there, 3 is equal to y. So y equals 3. So I need it to cross somewhere around here, which is 6, and somewhere around here, which is 3. Don't forget, it's a sketch, so it doesn't need to be exact. I'm going to draw myself a lovely straight line. Obviously, I would be using pencil in the real exam. So that is my straight line. Try and draw it as big as I possibly can. Okay, now I need to think about the curve. So I'm now going to think about q of x, and I'm going to plot the line y equals q of x. I already know that it crosses the y-axis, the x-axis, sorry, at x is 5 plus 3 root 5 and 5 minus 3 root 5. That is roughly around minus 1.7 and positive 11.7. And I achieved those numbers by typing it into my calculator. So the first one, which is around about minus 1.7, is not really far across the x-axis, so I'm going to say that that one is 5 minus 3 root 5, and 5 plus 3 root 5 was bigger than 6, so I'm going to say that that one's there. 5 plus 3 root 5. Don't forget, again, it's a sketch, so it doesn't have to be completely exact. I also know that I need to show where it crosses the y-axis, and it crosses the y-axis at negative 20 because that's the y-intercept. So I'm just going to mark on where I would like negative 20 to be. I'm then going to draw one smooth curve going through that x coordinate down to y and round. If I want to be even more clever, even though it doesn't say, I could also work out where this turning point is here, this minimum point. It doesn't ask me to find the turning point, so I don't have to. The key bits that I need to have on are my y-intercept and my two x-intercepts for my curve, which is q of x, and I label it. And then for my p of x, I need to know where it crosses the y-axis and the x-axis. If I don't show where my two curves intersect, I might also lose a mark because I have to show both graphs, and that includes where they cross.